So hello guys, we're back with 3 problems of kinematics from Pathfinder. These are very relevant problems from JEE advanced point of view. So we'll start the solution. Please attempt the problems before seeing the solution. So I'll start reading. From a place on the ground that is 20 meter away from a wall, a bullet is fired aiming at 50 meter high mark on the wall. So we'll draw the diagram. There is a point on the ground and there is a wall, right? It's 50 meter high, the distance is 20 meters. The ball is aimed to this mark. Suppose this is a projection angle because it is aimed to this point. So we can find projection angle, that is tan theta is 50 by 20 is 5 by 2. Tan theta is 5 by 2. We found out the projection angle. So we'll read the question again. Next, the location of the bullet is shown by a circular dot at some point of time. Where on the wall will the bullet hit? Okay. At x equal to 10 meter, the y coordinate of the bullet is 20 meter. You can see by scale 5, 10, 15, 20, 25. So it's 20 meters. So we'll use the equation of trajectory here. So if you guys can recall, y is equal to x tan theta, where theta is the angle of projection, minus g x square by 2u square cos square theta, right? So we can find u square because we know at x equal to 10 meters, the y coordinate of the bullet is 20 meters. So put y equals 20, x is 10 and tan theta is 5 by 2 minus g into 10 square by 2 u square. You can find out cos square theta, just use the right angle triangle. 5, 2, this is roots, how much? 27, root 29. So cos theta is 2, cos square theta is 4 by 29. Cos theta is 2 by root 29. From this, guys, find out u. Find out u from this equation. Then put it back again in the equation of trajectory. This time put x equal to 20 because they asked where will the bullet hit on the wall. That time the x coordinate of the bullet will be 20 meters. So just find the y coordinate. Where will it hit? I'm just giving you this as a homework. Find y coordinate and find the answer, and I'll proceed to the next problem. So what does the next problem say? A small ball is thrown from a foot of a wall with minimum possible velocity to hit a bulb on the ground at a distance L away from the wall. Find expression of height h of the shadow of the ball on a wall as a function of time. Okay. They have given us the range of the ball, which is L. So L is, if you recall the formula for range, u square sine 2 theta by g. They've said in the question that the ball is thrown with a minimum possible velocity. You can see here. So when can the velocity be maximum? And L is fixed, G is fixed. GL by sine 2 theta is u square. U can be minimum when this sine 2 theta is maximum. When is sine 2 theta maximum? And 2 theta is equal to pi by 2. Theta is pi by 4. So the angle of projection is pi by 4, and you can find out the velocity of projection also, which is root GL. They asked us to find the expression of for height h of the shadow of the ball on the wall as a function of time. So we'll draw it. Suppose this is the thing. The ball is projected and it hits bulb B. Suppose it is at some point here and its shadow is like this. They are asking us to find this height, and it's projected at an angle theta. Now if you draw the trajectory of the ball, I'll draw it separately. Suppose there is no gravity now. How will the ball go? Just go like this, like this, like this, like this, like this, right? Suppose there is no gravity, so it goes like it goes on like this. And if you use your intuition, actually this is the height of shadow, and the velocity of projection is u, and there is no gravity. And just suppose this is the height of the shadow. So it's very simple. Now we'll find h. H is y coordinate is uy into t. What is vy? Vy is root gl into sine theta. Sine theta is what? 1 by root 2 into t. Your answer is root gl by 2 into t. So this completes the second problem. We'll go back to the third one. The maximum range of a shell fired from a gun is r equal to 22.5 meter. Okay, there is a shell from which the bullet is fired, and the range of the bullet is, so a shell is fired from a gun and the range of that shell is 22.5 meter. This gun is mounted on a platform that can move horizontally with a speed v equal to 15. At what angle above the horizontal must the gun be aimed to achieve the maximum horizontal range, neglect air resistance, as well as the height of the gun? There is a gun like this, and we are firing at angle theta, and it is mounted on a platform which is moving at 15 meters per second. Right? That's what they said in the question. But initially the gun is fired such that the shell range of the shell is maximum. Okay. When can the range of shell be maximum? When theta equal to 45 degree. This is initial time. So 22.5 is u square by g. Sine 2 theta is 1 year. So from this you get u as 15 meters per second. And when you fire it the second time, the velocity of the range, means the firing speed of the gun won't change. So still it will be u equal to 15 meters per second. So they asked us at what angle theta in the second time the range will be maximum. So let's write the range. Range is what? Ux into t. We can write ux as 15 plus 15 cos theta, right? And time of flight. Time of flight is what? 2u sine theta by g. This is u, this is v. Okay, sorry, I will written it reverse. This is u, this is v. So we'll take v equal to anyways, so we'll take common. 2u square by g is 1 plus cos theta into sine theta. This is range as a function of theta, so you have to maximize this. So dr of theta by d theta must be 0. So I'm giving this as a homework. 1 plus differential of this, 1 plus cos theta and sine theta must be equal to 0. So solve this, you will get theta equal to 60 degree. I think you will get cos theta as 1 by 2. So this is the final answer. So at theta equal to 60 degree, the range of the shell will be maximum when it is mounted on the platform. So thank you guys for watching the video.